We have started with the dynamics of the system of the particles, and in last lecture we have seen the conservation of the linear momentum. Now suppose in a system of the particles there are n number of particles, and we have considered any particle as a ith particle. Now suppose the system is in a rotational motion, or if it is following some trajectory path, then it will have some angular momentum, and the angular momentum of the ith particle is given as Li is equal to Ri cross Pi, where this Pi is the linear momentum of that particle, and this is the relation between the linear momentum and the angular momentum. Now if we are considering the total system, so this total angular momentum of the system is given by summation of this Li, or I can write it as a summation of Ri into Pi, where I runs from 1 to n if the system is consisting of n number of particles. Now suppose this tau is the external force which is required for the angular displacement of the system of the particles, and which is given by dl upon dt. So this is the total external force acting on a system of the particles, and which can be given as dl upon dt. So I can write it here, d by dt of summation of Ri cross Pi. So if we solve this, it will be dri upon dt cross Pi plus summation of dpi upon dt cross Ri. So this summation of dri upon dt cross Pi, and if we put the value of this Pi as mivi, and vi d by dt of mivi cross Ri, and this v is nothing but dr upon dt again. So summation of dri upon dt into Pi plus summation of this d by dt of mi dri upon dt cross Ri. And we know that the cross product of any vector with itself will be equal to 0. So dri upon dt into this dri upon dt will give us 0. So this right hand side term will become 0. Therefore tau is equal to summation of dri upon dt cross this Pi. This is nothing but dl upon dt, which is equal to 2. So according to the Newton's second law of motion, we know that this dpi upon dt is nothing but Fi, where F is the total force acting on a ith particle, and which is given by Fi external plus Fi internal. So we can write the same equation, tau is equal to summation of R cross Fi external plus summation R cross F internal. So as we are taking it inside the summation, I will remove this I particle, because when we are saying the summation, so it will be over all the particles. And from the Newton's third law, we know that the internal interaction force between any two particles will be 0. So this term will become 0, and we are going to get this tau is equal to summation R cross F external. So we can say that whenever this torque is nothing but R cross F, which is nothing but dl upon dt. So we can say that whenever the torque acting on a system of the particles is 0, the rate of change of angular momentum is 0. So when this external torque applied on a system of the particles is 0, then dl upon dt will become to 0, and this L is constant. So when the external applied torque on a system of the particles is 0, the angular momentum of the system is conserved. So this is the law of conservation of the angular momentum of the system of the particles.